Hello and welcome to Nikolai's genetics lessons, and if you watch my previous videos about how to explain inheritance pattern, you should be able to explain this pattern. If not, it is very bad. I'm joking, it's just bad. Okay, what pattern do we see here? That in first generation, affected male, unaffected female, and in their children only girls are affected. And for example, if we take this couple where this female were affected, both female children and male children are affected about 50%. So if we take a couple where male affected again, only female children are affected. So this is very distinctive pattern. And we can explain it with X-linked dominant genetic disorder. So this male here have one defective X chromosome and one normal Y chromosome, and this female here has two normal X chromosomes. This daughter here, of course, should get one X chromosome from the mother side. It can be any of these, they are both normal. But from father side, she only can get this defective X chromosome. So that means that all female progeny in this couple are going to be affected just like this female here or this female here. So they are not going to have unaffected female children. But why male progeny are unaffected? 100% of them are unaffected because they got from the mother side normal X chromosome. Again, it can be any of these, but from father side they got Y chromosome. This specifies their maleness. Otherwise, they are not going to be males. So 100% of the male progeny in such couple are going to be phenotypically and genotypically normal. Now let's take a closer look at the progeny of this couple, and this male genetically unrelated to the couple in the first generation, so he's phenotypically and genotypically normal. Now let's take a look at the son who is affected. So what happened? From the father side, this male got Y chromosome, which is normal, and from the mother side he can get with a defective X chromosome or normal X chromosome. It turned out that he got defective X chromosome. This is X-linked dominant genetic disorder, and this male affected. What about this female? From the father side, this female only can get normal X chromosome, but from the mother side, 50% chances that she is going to get defective X chromosome or another 50% that normal X chromosome. And it turned out that she got defective X chromosome because this is dominant X-linked genetic disorder. This female is affected. As you see, those children in this family who are unaffected just got from the mother side normal X chromosome. So this male got normal X chromosome, normal Y chromosome from the father side, and this female got from the father side normal X chromosome and normal X chromosome from the mother side. So this explains why 50% of the children, both males and females, are affected, and another 50% of both sexes are unaffected. In this couple here, 100% of the children are going to be unaffected because this male has normal genotype and phenotype, and we also know that this female not just phenotypically normal but genotypically normal because this is dominant X-linked genetic disorder, and if this female normal phenotypically, that means she is normal genotypically, and that also means that all the progeny would be phenotypically and genotypically normal for this trait. And in this couple, in generation 3, we see in their progeny the same pattern as in the first couple in the first generation. So if male affected and female is unaffected and genotypically normal, that means that all male progeny are going to be normal in this couple. So they are going to get from father side normal Y chromosome and normal X chromosome from the mother side. But 100% of the female progeny are going to get one X chromosome from the father side, and father just don't have normal X chromosome. He can give to his female progeny only this defective X chromosome, and the other X chromosome they're going to get from their mother side, and still they're going to be affected because this is X-linked dominant genetic disorder. Very distinct pattern. One more time, if male is affected, only daughters would be affected. If daughter affected, then when she is going to be a mother, 50% of her female progeny would be affected and 50% of the male progeny would be affected, and the other 50%, regardless of the sex, would be unaffected. And then this pattern would repeat in the following generations. And this is all for today. Subscribe and see you in the next video. Goodbye.